All right, this is Workplace and Apprenticeship 30. This is 5.2, video 2 of 2. And so in example 2 here, we're talking about, this is a trapezoid, and it happens to be a special kind of trapezoid. Now if you look back, oh boy, I don't know what page that was now, but if you look back to the page that had all of the diagrams right here, okay. So there's a special kind of trapezoid where the two sides are the same. It's called an isosceles trapezoid. And they have the same length of sides, and also they would have the same same angles here as well. So go back to this example. Where were we? Right here. If we go back to this example, and what we can see is because those two angles are the same, we know that these two sides are the same. So that's 4 centimeters as well. So it says find AC. Well, we did that. Okay, this is a special isosceles trapezoid. Angle A and angle B. Now, this is isosceles trapezoids are perfectly symmetrical. So that means that this half is the same as this half. And so what we also know about quadrilaterals is that all 4 angles have to add up to 360. So 60 plus 60 degrees plus 2 times angle A, because that angle A is the same as angle B. So plus 2A equals 360. Now, we can set that up as an equation and solve for A, or we could just think through this logically. We don't have to, but we could look at it another way too. If you split this right in half, I have two 90 degrees here. If that's a straight up and down, right? 2 90 degrees. And so you could split that up into this plus 90 plus 90 plus 60 has to equal 360 as well. So let's see. Let's go back to this one. So that's 120 plus 2 times A is 360. 2A equals 360 minus 120. So that's 2A equals, what's that, 240? So A is 120. So that's what I get when we do it that way. If we split this up into 2 identical, smaller trapezoids like this, well, 60 plus 90 plus 90 plus A has to equal 360. And so what is that? That's 180 plus 60 is 240 plus A equals 360, and A of course is going to be equal to 120. So this is 120 degrees. Alright, so again we're using properties of isosceles triangles, noticing that this is there's properties of trapezoids, and this is an isosceles trapezoid with those 2 angles being the same. Okay, second part of this then is about this kite. So this is a kite. It is a 4-sided figure where the diagonals meet at 90 degrees. And one of the properties of kites, if we go back to that diagram as well, is that these 2 sides will be the same, therefore these 2 sides will be the same. So if we're looking for WX, because this is 2, this is going to be 2 centimeters, of course. And let's see, angle X, Y, Z. So that's X, Y, Z. So that's this angle right here. We need to find that one too. Well, you see this is a very symmetrical shape. So if this is 101, and all of these sides over here are the same, and all of these sides over here are the same to that, this angle has to be 101 as well. Okay? And so here's the solutions from the textbook. Angle A and B are 120. The side is 2, and the angle should be 101. Okay? So the sum of the interior angles of a quadrilateral is 360. And I guess there was another question there. Was there another part to that? Oh, and what is the sum of WXY and WXY? That's this one. And YZW. YZW, this one here. So what are those? What is sum of those two? Well, if this is 101 and this is 101, then all 4 sides have to add up to 360, and that's where they get that from. So 101 plus 101 plus 101 plus x plus z will have to equal 360. Okay, so that means that the sum of these two, that's wxy and this is yzw, the sum of those two have to add up to 360 minus 101 minus 101. And so the sum of those two angles, I'm just showing these angles a little bit differently here. Those are the same as these two. That's going to be 360 minus 202. What's that going to be? It's going to be 158. So the sum of those two is 158 degrees. There we go, right there. So here are build your skills questions for this part here. There's number 3. And here's number 4. And then we'll do example 3 here together as well to round off this section. So this example says this: a rectangular window is to be constructed with strips of colored glass that run parallel to each other and diagonally as shown. At what angles must the glass cutter cut each of the indicated angles? So if we zoom in here, number 1 is down here, and we're also given that this is 38 degrees. This is number 2 as well. So here's number 3 and number 4. So interestingly enough, what we want to pick out of here is, let's say for number, let's say for this line right here, I'm going to highlight that line. I'm also going to highlight this line. Now these strips of glass are parallel. Okay? So that means we have two parallel lines here. And this side right here, I'm going to extend this side here, but this right here is a transversal. And if you think about this, if these lines were to be extended like this, we have two parallel lines cut by a transversal, and therefore corresponding angles, like the angle 38 and angle 1, are equal. So angle 1 is 38 degrees. Now angle 2, if you notice, angle 1 and 2 are the same side interior angles to two parallel lines, right? And so these angles right here from our work before, we know that 1 and 2, angle 1 and angle 2, let's write it down here, have to add up to 180. They are supplementary.
Rashida, please come to the front doors, please.
And so if angle 1 is 38,
front doors,
let's make that a 38, plus angle 2. So angle 2 is 180 minus 38. So angle 2 is going to be, what's that, 142 degrees. So there's angle 1, there's angle 2. We're picking them off here. So now if we look at angle 3, well, what's interesting is that we have a bit of, we have a quadrilateral here. And it looks like, are these uniform width? Well, run parallel. Okay. Well, I guess what we could look at is, we could look at, I was just going to say that looks like an isosceles trapezoid, doesn't it? If those are parallel, yeah, it's rectangular, so I guess you could say, because these are 90, right? That's an isosceles trapezoid. So yeah, so angle 2 and angle 3 should be the same. Angle 3 should be 142 as well. And angle 4 and angle 1 really should be the same. So let's say that is 38 degrees. Okay. So that's example 3. Let's see how they did it here. Yeah, so 38, 142, and 142, and 38. Isosceles trapezoids right there. Okay. And then here are the build your skills questions for video number 2. We're going to round out this section here, the practice your new skills questions.